afternoon takes over, and I will talk also VPN. And we can talk about the case studies, how to implement that. Yesterday, Mr. Anandam sir was asking about how to implement, what is the case studies, how we have delivered the user cases. We will talk on that. So that is the flow. And also I have been asked, what is the tariff? That is the costing of normal internet, and what is the costing of the MPLS. And this we will relate to, you are all using the e-office. How it is connected to your e-office, we will be talking on that. This is the flow for the first half of the day today up to 1 o'clock before lunch session. Okay, yeah. Let me take over to the internet protocol, that is IP. What is exactly the internet protocol? It is internet protocol. It is a set of the rules how the computers can communicate over it. There are two types of the internet protocols. That is the IP version 4, that is IPv4 we call, and IPv6, that is the latest one, which has got a number of IPs than the more number of IPs than the VP4. What is an IP address? An address is identifier for a particular machine in the network, because network can't identify by names. All of this we have seen that names are also, we have a shortage. So that's the reason the IP address will be identified by a network with a particular number. What are the network machines are there, or the computers are there, will be assigned by every computer machine will be assigning one IP address that will be identified in the network. IP address also sometimes identified as IP number or IP address. So the network portion, IP has got two portions. One is the network post, other is the host post. Host is nothing but the user who is connected onto the network, the computer, tab or mobile, whatever it is. The network portion of IP address is allotted by the network portion addresses will be allotted to the service provider by the INA, who is the agency for assigning the internet addresses. The ISP will assign the host user numbers will be assigned by the ISP. ISP is nothing but internet service provider who is catering into that area, either geography, district-wise, state-wise, and the country-wise, and global-wise. Which section of the IP address represents the network and which section of the represents the machine depends upon the class of the IPs what we take over. There is called a classful addressing system. IP address was first standardized in 1981. Each system is attached to the IP-based internet assigned by unique 32-bit address system. We will see what exactly the 32-bit, how it is arrived at. The 32-bit addressing system involves the two level of hierarchy. Just now we spoke about the network addressing, the host addressing, that is network number, host number. Host is nothing but the user. What is IPv4? IPv4 was the first version of the internet address which is being used till yesterday's. But today it has got only 4 billions of IP addresses, IPv4. While today the demand is more. Today we have seen IoT, Internet of Things. Every machine connected to the Internet of Things has been assigned. So we have a shortage of the IP pool, that is IP addresses. That's why we migrated ourselves to IPv6. We will see what exactly the IPv6. IPv4 has a 32-bit number represented by 4 decimal number. Each decimal number is 8-bit, that is 1 octet. I think this we need to understand bit the digital electronics and all. Thus, the representation is known as a dotted decimal representation. IP addresses consist of 2 components. Just now we spoke network as well as the host IDs. Network ID, it is a number assigned to the network in the internet by the INA. Host ID represents the user in that network. IPv4 2 port 32. 2 port 32 gives almost 4 billion unique addresses that will be available with IPv4. All these IP addresses are differentiated depending upon the class of the network, how it has been used. All host IDs are dependent on the class. One is called class A, class B, class C, class D, class E. We will see exactly what it is. Class A, there are four. Just now we spoke about there are 4 bytes. 4 bytes means each byte will have 8 bits. So likewise, it has got 8 bits, 8 bits, 8 bits, 8 bits. Total 32 bits are there. The first class A, first byte, that is 8 bits, denotes the network. Then last 3 bytes, that is last 24 bits, represents the users. The range of the IP number starts from 1.0.0. to 126. We will see how this figure is arrived. The number of possible networks available in this is 0 to 127. Class A. If you see, just now we spoke about it is a 4 byte number. Each byte means 8 bits. So 4 into 8, that is 32 bits. 32 bits on that first 8 bits represents the network. Remaining 24 represents the host, that is the users. In class A, the number of possible values, the host portion is 1.6 crore. 1.6 crore. That is 1.6 crore hosts will be available in this. Basically, it is used for the large networks. In class B, the 2 bytes, that is 16 bits, are used for the network. Remaining 16 bits are used for the users. So it starts from 128. You are seeing starting from 1 to 126 is used for your class A. 128 to 191 is used for class B. The number of possible networks in this are 16,384. Number of possible networks. Just let us go back to the old one. In class A, the number of possible networks are 127. Possible networks, and each network you can have 1.6 crore hosts, 1.6 crore users. So the total number of users available in class A are 1.6 crore into 127. That many hosts can be accommodated into class A. Similarly, in class B, you have total possible networks are 16,384, and the number of hosts connected in that are 65,536. That is a total number of users that can be connected in that are 65,536 into your 16,384. That many users can be accommodated in class B. Similarly, we have a class C, 3 bytes, that is 24 bytes are used for the network ID, bits are used for the network ID, and remaining 8 bits are used to represent the host, that is a user. So this is ranging from 192 to 223. So the number of possible networks in that are 20,97,000 networks, and it will be connected to this network, and each will have 256. That means 256 into 20,97,000 users will be connected in class C addressing system. This way, class A, class B, class C will be connected, and you have a first octet will have the network, remaining all are hosts in class A. Class B, both 2 bytes, that is total 16 bits are used for the network, remaining 16 bits are used for your host, that is users. In class C, first 3 bytes, that is total 24 bits will be used to represent the network, and last 32 is representing for the users, that is hosts in class C. Let us talk about next one is class D. IP address which belongs to class D starts from 224 to 239. This is basically used for multicast purpose. It is not used for commercial traffic. It is used basically for the multicast purpose. And we have a class E, which is reserved for the experiments and for future testing purpose and all, which ranges starting from 240 to 255. This is way how the classification of the IP addresses have been done in IPv4, that is a version 4. Next, what is IPv6? IPv6 is, see, today we have a challenges of depleting the IP addressing system of the 4 after the mobile communication evolution, now you see a lot of the users have increased. So assigning IP addressing is not sufficient with IPv4. So that's why we switched over to the IPv6 in 1999. Thereby the IoT industrial first started industrial IoT. Then we moved to the IoT. So every device connected on a network requires an identification of an IP. So that's why we need to have more IPs. We move to the IPv6. What is the difference between IPv4 and V6? We will see. The major difference between is IPv4. There are only 4 billions of IP addresses in IPv4. In IPv6, can anybody count and tell me how many IP addresses are there? There are so many IP addresses which will be sufficient for next 2 generations of us. Next 2 generations is this IP address will not be having any problem with this IPv6. The technical function of internet remains the same for both IPv4 and IPv6. And both will keep continuing operation. It doesn't mean that when IPv6 has come, IPv4 will die. No, both are interoperable. In the current time, the networks uses IPv can support IPv4 also addresses in their networks. The definition of IPv6, which makes use of 128-bit IP addresses, whereas IPv4 uses 32 bits, 2 power 32. 2 power 32 is 4 billion. 2 power 128 is that what we have seen. Like IPv4, it is represented by 4 bytes. Here it represented by 8 groups of 4 hexadecimal digits, each group representing 16 bits, that is 2 octet. So that's the reason we could able to get more IP addresses in IPv6. Difference between IPv4 and V6. Addresses are 32-bit, here addresses are 128 bits. Both routers sending OS fragmented packet, it doesn't send the fragmented packets. Header includes the checksum. In IPv4, it doesn't include checksum. We have a class A, class B, class C, class D in IPv4, just now we have seen. The similar to that in classes IPv6 are unicast, anycast and multicast. The IPv4 can be configured manually. Yesterday we spoke about manual configuration and configuration through DHCP, dynamically hosted protocol. But IPv6 doesn't require a manual, it does automatically. IPv4 uses the dot decimal, it uses the hexadecimal. IPv4 is not suited for mobile networks. IPv6 is the best suited for the mobile networks. So you see the larger address space is available with IPv6, 128 bits. You see how many addresses. This is the header for IPv4 and V6. Like classes of IPv4, class A, class B, class C, class D, unicast, multicast and anycast. Why IPv6? We spoke already. Deficiency of IPv4 addresses, address space exhaustion. There are the new type of integration that is required for multicast. Quality of service. We will talk more quality of service when we talk about MPLS and VPN. And security. Yep, IPv6. People arrived called mobile IPv6. That is IPs for mobile communications. So this is all about the IP addressing system. Having this IPv6 in place, some of the challenges have been totally addressed. But before introduction of IPv6, we have a tough problem with IPv4, where we used to use the IPs translating to private to the public, public to the private. That is called NATing, network address translation, and port address translation. We will look quickly onto that because now we don't be having any challenge with IPv6 for at least next 2 generations of us. after understanding the IPv, we should know how to subnet the IPs. I think many people might have heard call it subnetting. Yeah, many people might have heard the called IP addressing and subnetting. We will see what is the benefit of subnetting, how the subnetting will be done. A bit mathematical one, just to understand it. It is the function of the network administrator to do this job. Again, we spoke about 32 bits is IPv4 and IPv bit and byte, we all know it. And this is the conversion of the binary to the decimal and vice versa. All will be represented by the 2 to the power 1, 2 to the power 0, 2 to the power 7, 2 to the power 6, likewise. So the 0 represent in the decimal value 0000000 in binary. The 255 all ones, that is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8. So this all will be, if you combine all this, 2 to the power 1 is 2 to the power 0, 1, 2 to the power 1, 2, 2 to the power 2, 4, 2 to the power 3, 8, 2 to the power 4, 16, 2 to the power 5, 32, 2 to the power 6, 64, 2 to the power 7, 120. If you add all together, it will come to 55. Similarly, 15. 15 is, this is a 1, this is 2, 3, 3 plus 4, 7 plus 8, 15. So this way, how you convert binary to the decimal. This understanding is required while doing a subnet masking of your IP address. By doing the subnet masking, you are able to increase your hosts, your users, by giving in one particular ID, that IP, you can subnet it and you can accommodate more users with the subnets. We will see how that is. See, just now we spoke about binary to digital, decimal and decimal to binary conversion. Subnet mask 256 to 192. Why 256? 256 is what? All ones. All ones. 1, 1, 1, 1, 1, 1. All ones, that is, you have seen here, all ones are 55. Is 0 to 255 or 1 to 256. So 256 is your all ones. Next, 1, 1, 0, 0, 0, 0. Then it becomes 192. So the subnet masking is 256 minus 192. The first subnet starts with this as a 64. From the 256 to 224, the subnet masking is 32. 256 to 240 is 16. 256 to 248 is 8, and 256 to 252 is 4. This is where how you do the subnet masking. See that. Again, we have a 32 bits network and host. Each has got 8 bits of 4 bytes. You see, each byte will be 1, 2, 3, 4, 5, like 128, 128, 128. So total 32 bits. As we have seen, 1 is the network, remaining 3 hosts for the hosts. The class B, we have 2 network and 2 hosts, 2 bytes, and class C, 3 bytes for the network and 1 byte for the host. What it means, when you use the class A, you can connect many users. That means network is 1 and many users are there. 24 bytes you have a users. Similarly, in class B, it is a medium. You will have a 2 bytes for the hosts. And class C, very small one, that is only you have 1 byte for your hosts. Again, we have seen D is a multicast, E is for research. How to do IP address? See, every class A up to 126, we already spoke, this is class A. Again, 128 to 191 we discussed as a class B, and 192 to 224 we discuss it as a class C. So this IP address starting from 10 is a class A. 10, 72, 92, these are all private IPs. Private IPs. The difference between private IPs and public IPs are already broadcasted. Routers cannot be purchased in a shop like a chocolates or your computer. A router IPs are not available in the local market. IPs you not be purchased in local market. When we started internet in 95, there is a huge shortage of IP addresses in India. Our people, we have people working across the globe, Indians, NRIs, they used to get the IPs there, but it is not able to work in India because it has to be routed. All IPs has to be routed in a router by the service provider. So the public IPs are the IPs that are routed, available on a network, whereas the private IPs are available, which needed to be translated and mapped to the public IPs. That's what we talk about the NATing. So the 10 series is a class A private IPs, 172 is class B private IPs, 192 series is class C private IPs. 10.0.0. is basically a network address. The first valid host, the first user can be connected in this is 1.0.0.1, and the last user connected on this IP pool is 10.225.225.225.254. The last 255 users for the broadcast. Yesterday we spoke about routers. That's a lot of the broadcasting. We have to reduce as much as possible the broadcast for a router to function efficiently. So you see how many hosts can be connected in this way. Similarly, for 172 class B private IP, the network address, the next is the first host, the other one is the last host, this is the broadcast address. Similarly, for class C, you have network address, you have the first host, you have the last host, and this is the broadcast address. Address without the subnet. Now we will see the subnet. Subnet will increase the number of users for given particular IP address. See, this is a network as having 172.16.0.0. Invariably, this is a class B IP address. This has it don't have any subnet. How you know the subnet? 172.16 is a class B, that is 2 bytes are used for the network. Remaining 2 hosts are used for your hosts. By seeing this we can say class B IP address without any subnet. Okay, like that the network first IP will be 172.0.1 to up to 255.254. This is many hosts will come without subnet. Now we will see what is the subnet is. In this network of the same 172.16.0.0, it has started with 172.16.10.0, 20.0, 30.0 and 40.0. Whereas this is a class B address having 10, 20, 30, 40 into the third byte of your IP address represent this as having a subnet. Am I clear? Yes, Anandam. Yes, Anandam Garu. Yeah. Right.
Yes, sir, clear.
Yeah. Then generic subnet mask default class A 255.0.0.0, for class B 255, class C 255. How to calculate the subnet mask? 2 to the power subnet bits -2. This is the formula, just to remember it. Anyway, this presentation is with you. How many hosts for the subnet will give number of host bits? When I say the subnet bit 1100000, total 8 bits are there. First 2 are having 11, that is 192. 192, 2 bits are there, that is subnet bits are 2. Remaining host bits are 0000, total 6 are there. Altogether 6 plus 2, 8 makes 1 byte. So 2 to the power 2 minus 2, that gives the number of subnets into particular class C subnet masking. We will see how it is calculated. Example, this 192.168.10.0. It is a class B or class C or class D. Any input, please? Sir, this class
C. Class C.
Excellent, sir. Excellent. It is a class C. So this class C IP address, it has got 192. 192 is the last host. 192. This 192 becomes, how 192 is arrived? 1 after all zeros. If you can add all that, this thing, it becomes 192. That means there are 2 bits are for the subnet. That is 2 power 2. That is 4 minus 2, 2. That means with this IP address, you can make 2 subnets. What subnets? Where it starts? 256 minus 192, 64. 64 is one subnet. As I told, there are 2 subnets. Next subnet will be other 64. That is 64 and 128. 2 subnets can be made with this class C IP. And how many hosts will be there in each subnet? There are, out of that 8 bits, there are 6 out of 8. 2 becomes 1, 1. Remaining 6 are 0. That means number of hosts will be 6. There are 2 power 6 minus 2. That is 64 minus 2, 62. 62 hosts will be there on each subnet. So the network address will be 64. Afterwards, the next will be 65. From 65, you can have 62. Total hosts. The last will be the broadcast. So similar way, this way. Is it clear?
Yes, sir. Clear, sir.
Good. Then how you are going to implement that? You have calculated the subnet mask, but you have to implement it. You have to configure it. You have to add to your router. So now you are seeing this is a network of 192.168.10.64. Other one is 192.168.10.128. So from 128, the first number will be 129. So the 129, 130, 131, 132, it keep on going like this. Other side is 64 is your network address. First host is 65. So 64, 65, 66, 67, 68. And that way you keep giving the numbers up to 255, 254. So this way you can add your number of hosts by using the subnetting. So the easy subnetting with the subnet mask is 224. You imagine, you just understand here, the first subnetting, what we have done, the last will be 191 only. The last broadcast is 191. Similar way, for this last broadcast is 23. It has to end at this point of 224. The similar way for this is the last point is 230, 239. The one is last is 47. So this way, how we can keep doing the subnet masking. Similar way, how we implement this. What we have seen earlier is class B. Now this is, earlier we have seen is class C. Now this is for class B. You see this class B, you have both bytes are of this thing. Remaining 2 bytes are used for the host. This shows this is a class B. In class B, you have 192. Again, similar way of earlier, 2 power 2 minus 2, 2. But now you see here 2 power 14 has come. Why this 14 has come? Total bits available are 8 plus 8. Here 8 bits, here 8 bits, total 16 bits. Out of the 16, the subnetting will be for the 2. Remaining 14 bits are hosts. That is 14 minus 2. So this is this many hosts can be accommodated in each subnet. This many hosts can be accommodated in each subnet. That means it starts network address with 64. The first will be 61, 64.1 up to 127.254. That is the last host, and 127.2555 the broadcast. This is for one subnet. Similar way for other subnet with this 128 is 1 and 128.1 first host, and last one is 191. This is the 192 is the last here, 191 is the last 254, and the last will be the broadcast of 191 point. So this many hosts you can accommodate by doing the subnetting. So the same thing. So this is way how you do the subnetting. This subnetting process is clear to all of you? Or anyone want to be explained again, please? Yes, Anandam Garu?
Continue, sir.
Continue. Okay, fine.
Continue, sir. Continue.
Good.
Because we deal all these things in our training courses, sir.
Excellent, sir. Excellent. I think you are all masters. You are a master.
No, not like that, sir. Regularly we deal all this IP networking.
Subnetting also. Good.
Very good, sir. Very good. Thank you.
Good. Having these IP addresses now, we have in spite of doing all these mechanisms to enhance the host numbers, we still have the challenges with IPv4 initially. So now we started using the network address translation. The meaning of the network address translation is to map the private IP with the public IP. When it goes to the internet cloud, it understands only public IP. It don't understand what your private IP is. So the conversion will be taking place, the transaction or the translation, that is called network address translation, that happens either through a firewall or at the router level. Okay, yeah. IPv4 address spaces, we have a challenge. That's the reason we are going the NAT process. NAT is process used for transition. These are defined in RFC standards. You see now here, just now we spoke out in class A 10. This is a private IP in class A, 172 is private IP in class B, 192 is a private IP in class C. See the process here, this is a router which does need network address translation. You have a pool of internal IPs, that is private IPs, that need to be translated through public IPs through this NATing process. NAT is a process used to translate the network addresses. It is basically used to conserve or save the IPv4 address. Importantly, NAT is implemented at the border network device, that is the last device which enters to the internet cloud. Either through a firewall will be the first point for you to checking. Likewise, the router will be the last point in your network to get out or get into the packets. NAT allows the network user private addresses internally only transacting. Suppose when any user internally wants to transact, you don't need to go to the network and all. You can use internally, you can able to communicate by using your local IP. Your packet won't be going all the way to the public cloud. So there won't be any much delay while communicating within the private IPs of your network. How this NATing is enabled? This router enables the NATing. These are the private IPs NATed to the public IP on the network 209.165.201.1. This is the public IP on the internet cloud. This server, this is the server static IP coming through this ISP. So these are the private IPs within your organization. By doing this router NAT enabled, you can able to translate all these IPs where they want to reach the external world. If you don't do this, these people cannot go to the external world because external world cannot recognize these IPs. NAT terminology. There are the different terminology what we use. The source address inside the local, destination address outside the local. Otherwise, the same way, destination address outside the global, source address inside the global. These are the terminologies that is used to identify a particular private IP and a public IP. So this is 192 private IP. This is the internally this IP has been assigned. The site is called inside local of the source who is sending the request now. Similar way, it goes to the external world, and the response has to come from outside this network. It has to come from response from 209.165.201.1. So this is the global IP inside this, that is source ID inside the global, destination ID which is going towards outside the global. This way how the terminology is used in the NAT. The NAT terminology, how it maps, how it connects. Now you see the PC1 having a local IP, local, that is a private IP of 2, local IP here of 109. Has to go inside this network, has to go to the internet and reach this outside the global address 209.165.20.1. So this is way how the NAT table is being mapped by the system itself. Network administrator does all these jobs. There are the static NATing and dynamic NATing and all. So just go through, just not much relevant. Dynamic NATing, what happens is one address will be used by available, see there will be one local IP. There are many, you have addresses on the global. So 1 to n. 1 to 1 is a static, 1 to n is the dynamic. Next, coming back to the port address translation. Yesterday we spoke about the ports 20, 21 for FTP and so on we spoke. Sometimes this port address translation is used before this NAT and all. So this is all irrelevant as of now because we have enough pool of IP addresses in IPv6. So this was interim arrangement was made before the IPv6 brought into the picture. The main disadvantage with NATing is, suppose you want to ping, you want to trace route. End to end you can't do it because you are using a private IP. That private IP is getting translated within your router endpoint of your border route. Beyond that, it is not going. So you can't know exactly the end-to-end functionality and traceability of your packet which is originated from your private IP. NAT4 is not much required. For IPv6, we have enough addressing systems. NAT is used basically for IPv6, is basically between IPv4, IPv6 to find out exactly the communication. So that's all about the NATing and all. Now we will be talking of, now we will be talking on the LAN, WAN and all. Yesterday we already spoken on something. We'll quickly run through because to understand this VLANs, creation of the VLANs, and we should understand a bit LAN and WAN, just brush up our knowledge. Anandav Garu, did you all covered VLANs also in your labs?
Sir, mostly we cover, sir, but you can refresh it, sir. No problem. Okay, sir.
Okay, fine, thank you. Yeah. Yeah, the LAN basics yesterday what we have studied 803.3, 803.5, that is the Ethernet 803.3, 802.3, 802.5, that is your token ring and all. Just we will brush up that. Again, the new component is coming is fast Ethernet channel. A number of Ethernet channel combined together, trunking to them, it becomes Ethernet channel. The same way gigabit Ethernet becomes trunking of all gigabit Ethernets becomes Ethernet channel. Yesterday we discussed on this Ethernet IEEE standard 802.3 and we also discussed IEEE 802.5, that is a token ring. This all 802 represents basically the LAN. You might have seen this configuration on your router, switches and all, 100 place FX, 100 place T, 100 base and all. I think probably you may be knowing all these things by that time, but it is for me to refresh that. 100 represents the LAN speed, how much speed that takes care. It is basically 100 BPS. BPS, bits per. Today bits are peanuts. Today we'll talk about gigabit, terabit, petabit, yotabit. That much size of the data, we talk big data, big pictures. Base stands for either the baseband or the broadband. FX stands for F is a fiber. X that returns there shows the length that can driven by the, suppose you have a switch. How much, so take example, you have a switch. How much distance the switch can able to drive? Suppose you are connected through a fiber cable or connected through a cable UTP Cat5, Cat6, Cat6e. How much distance that can be driven by the cable represent by using this. You see this, the table. 10 base 2, the maximum distance it can cover is 185 meters. This is a 2 into 100, that is 200 meters it can cover. 10 base 5, it can cover only 500 meters. 5 into 100 meters, 500 meters. 10 base, likewise, by seeing this we can come to know. You see the fiber optic FB, 10 base FB. F talks about fiber, and the baseband it takes up to 2 kilometers. Other is 10 base FL. It is a fiber, it can go up to 1 to 2 kilometers. So likewise, by seeing this, what exactly it resembles is internet operation we have seen yesterday. And this is the process, how the Ethernet transmits, how the host, when the host wants to transmit, it first senses the detection, assembles the frame, and starts transmitting the frame. If the collision is detected, and keep transmitting it till the packet or frame lives, that is a TTL. If the transmission is done, transmission completes. If the broadcast jump signal observes, then it attempts for one more time of transmission. If attempts are more, the packets get discarded. This way how the process takes place. This is a fast Ethernet channel, grouping of multiple fast Ethernet interfaces into one logical. That's what we discussed already. What is a gigabit Ethernet? 1 Gbps data rate, 8.2.3 on Ethernet frames. Compatible with existing protocols, operating systems, and applications and the managements. When we talk about the network application, that is SNTP, FTP, FNS, and so on. Token ring we discussed yesterday, IEEE 802.5, which is developed by IBM, is a proprietary tool. This way how some madam was asked how the token ring function yesterday. And these are the, each in the ring, it keeps sending continuously the tokens. Because of sending continuously, you are occupying your capabilities. Network sources are. Next we discussed yesterday FDDI, Fiber Distributed Data Interface. We discussed it also. Similarly, we have a copper CDDI, Copper Distributed Data Frame. Basically the LAN concept of it. It is connected in the ring form. LAN is connected to the WAN here. So the gigabit stack GBIC interface connector looks like. This is the gigabit Ethernet module on your router. How it look like. Now we'll talk about the WAN. WAN. Many users to serve about a network that serves across the broad geographical area. Fortunately or unfortunately, we use for our data communication still our telephone lines. All our telephone lines are basically meant for to carry 3.4 Hz to 3400 Hz voice signals. But that we started using for transmitting the data 2 meg, 10 meg and all. And now all we are replaced with a fiber to carry gigabits and terabits of the data of the order of the day requirements. WAN functions at the lower 3 layers of OSI. What are the layer 3? Physical, data link, and network layers. These are the WAN devices. And this is the WAN terminating equipment. Many people you might have heard called DTE and DCE. Data terminal equipment at the customer premises and the data circuit terminating equipment at the service provider premises. These are the transmission PUX is a temporary connection oriented. ISDN temporary. We have seen PRI, BRI lines, ISDN, and we spoke about the leased lines, T1 system, E1 system. Frame relay, X.25 protocol, very famous for banking applications. DSL, a point-to-point protocol, a WAN. Integrated ISDN, PRI 144 Kbps, and you use the PRI line, that is 2 meg, 2048 kilobits. And we have a T1 also, it gives 1.55 meg. Each channel capacity of 56 Kbps into 24 there. Here 30 into 32 into 30. The leased line. Frame relay. Yesterday we spoke about the frame relay. What exactly happened? The fun thing in frame relay is your service provider, for that you will pay some bandwidth of 2 meg. Your 2 meg is assured for you. That is called committed information rate. It is guaranteed for you. Suppose if the bandwidth is available, nobody is using into that network and you wanted to use that, yes, you can get more than 2 meg. That is called a peak information rate, PIR, CIR, PIR. This is called BIR, burstable information rate. So you have a CIR, burstable information rate, peak information rate. Without paying for this burstable information, you are going to get at the same cost if it is available free. That facility is available only when we start using the frame relay circuits. Again, we have a metropolitan area network, that is a MAN. We have all the names called MAN, metro area networks, so MAN, metro ether networks, MAN. So likewise, all these networks, we have storage area networks. Okay, after understanding WAN, LAN, we talk about the virtual local area network, VLANs. This VLAN creation is a must for creating the VPN circuits and also secured network provisions. What are the challenges with our existing LANs? Anand Garu, just tell me when you want me to break for the tea or questions.
Okay.
Now we can ask for questions before we go for VLAN.
Better.
Okay, I think VLAN will start after the break. Oh, no problem. Yeah. Any questions, please, sir? Yeah. Yeah. Any questions so that I